This video will tell you all there is to know about Impro's distributed controller. Here are the chapters we'll be covering. You'll also find hyperlinked timestamps in the YouTube description below the video. The Impro distributed controller provides all the control, communications, memory, digital inputs, and relays required to serve up to 2 doors. Working our way around the controller, we begin with the 2 reader ports. These cater for RFID tag readers, fingerprint readers, non-contact hand readers, facial recognition readers, and UHF remote receiver. They retain legacy capability for Wiegand multidiscipline and other devices such as magstrip readers. The 12-volt DC outputs can supply up to 350 mA to power a reader. 12-volt power for the readers is provided at these 2 pins. The Ethernet port connects the controller to the access control application, or in the case of small installations, this provides network access to the onboard access portal AP Lite access control web application. All the input and outputs for the control of 2 doors are provided, catering for exit buttons, door closure sensing, and relay connections that allow for wiring flexibility. A 3rd relay can be configured via the access control software to switch other loads. The RS485 DC-SC port configures as a system controller master or a door controller slave to link these controllers over distances up to 1,000 meters. This is useful when doors are far away from Ethernet access. The RS485 aux port and its adjacent 12-volt DC power output terminal can be used to control and power Perio hubs for wireless lock systems. These are great for eliminating much of the wiring that is typical around access control doors. The electronically fused aux 12-volt outputs can supply a maximum of 350 mA. These 4 terminal blocks at the top here provide housing tamper detection, indication of AC power failure, and low battery voltage. The DC power input terminal. Maximum DC current draw for the controller is 2 amps. Note that the distributed controller is offered in 2 different voltage variants. Controllers with the light grey lids have a 12-volt DC input, and controllers with the dark grey lids will accommodate an input voltage in the range from 12 to 24 volts. We'll now run through the different housing arrangements and power supply combos that are available. The HCD900 is a standalone distributed controller with accessible terminals. This will need a DC power supply, which is not included. Make sure that the power supply voltage is suitable for your model. The HCD901 is pre-installed in a steel cabinet with an integrated DC power supply, or IPS. It has an AC mains input terminal block and space for a 12-volt SLA backup battery. The power supply includes a tamper switch which is activated when the cabinet door is opened. The HCD902 variant is like the HCD901, but the AC terminal block has been replaced with a mains input socket. The 902 also has an anti-tamper switch plate that can be used to trigger an alarm if the cabinet is proud off the wall. The HCD903 is like the HCD901, but instead of a mains power input, these have a built-in power over Ethernet adapter. The HCD905 is pre-installed in a plastic housing, which can provide improved environmental protection. A wired anti-tamper switch detects when the lid of the housing is opened. This unit requires an external DC power source. All these combos are available with the 24-volt version of the distributed controller. Look for the dark grey cover and the figure 2 in the item number. Every distributed controller combo comes with a unique quick start guide that is tailored for that specific hardware combo. In addition to the quick start guide, there are also 3 metal oxide varistors, 4 jumpers, and a spare address label. We know that you may be removing the grey lid, this lid. So all distributed controllers are shipped with only 2 of the 4 screws fitted. The remaining 2 screws are included in the packaging, together with a spare, so that makes 3 screws in the packaging. All fully enclosed combos will include 3 wall plugs with screws, suitable for mounting the housing on a masonry wall. The 902 variant includes a cabinet tamper bracket and an extra wall plug to secure this bracket to the mounting surface. All steel cabinet combos include 4 spare cable ties and 2 spare cable tie cradles. The power and anti-tamper related wiring is already factory installed. You'll need basic electrical installation tools and the following additional hardware to complete the installation: cables for Ethernet, readers, door sensor inputs, and the locks, or other relay loads. Establish the cabling requirements. Measure the distance to AC power outlets and Ethernet connections and consult the device installation guides. You'll need magnetic reed switches for the door open sense function, push buttons for exit request, mag locks or strike locks. You'll need readers. These can be RFID tag readers, mobile Bluetooth, or fingerprint or facial recognition devices, or a quad receiver that will allow remote operation using 4-button UHF key fob transmitter. The HCD 900-920 model is not supplied with any fasteners for mounting the controller. The standalone controller base is 10 mm thick and it has 4 mm mounting hole at each corner. You must obtain fasteners that are suitable for the mounting surface. The DC power planning chapter of this video will discuss power adapter requirements. Here follows all the specifications for the various cables and the relay contacts. Pause the video when you reach the info that you need. Here we have the reader cable specifications. Here are the network cable specifications. Notice you'll need the heavier Ethernet cable if your controller uses power over Ethernet. Here we have door wiring cables and the controller relay contact ratings. Please note that the controller's warranty is voided if relays are not protected with the provided metal oxide varistors. More on this on the wiring electric lock section. This table shows the maximum currents for the power input and power output terminals. The HCD 900 and 905 combos do not include any DC power adapter. You'll need to obtain a power adapter that will accommodate the DC power needs of both the controller and all downstream devices. That's if they don't have their own DC power adapters. Consult the specifications for all the DC power requirements of all the devices that don't have their own power supplies. Add them all up, including 2 amps for the controller, and then obtain an isolated DC mains adapter as necessary to safely accommodate the total DC power needs. The HCD 920 and 925 have the dark grey covers on the distributed controller, which means you can power these from an isolated DC source anywhere from 12 to 24 volts. Take care not to connect 12-volt devices to 24-volt supplies. Steel cabinet combos have a factory-wired intelligent power supply that manages the backup SLA battery. There are also 3 auxiliary 12-volt power outputs that can be used for devices such as electric strike locks and mag locks. Consult the specifications for all such devices that you need to install. Add up the total 12-volt current consumption and make sure that this does not exceed the 2.5 amps. If more 12-volt DC power is needed, you'll need to obtain suitable isolated 12-volt DC power adapters to make up the difference and factor in a safety margin. We recommend installing the 12-volt SLA battery for 2 good reasons. The controller and its peripherals can continue to operate during short AC power interruptions. Short duration high loads are easily accommodated by the battery. This could save you from having to install an additional DC mains adapter. When it comes to mounting the controllers, select a mounting location that is on the secure side of the access door, sheltered from the weather and free from vibration, while at the same time strives to minimize cable runs. HCD 900 and 920 models have 4 4mm mounting holes, one in each corner, as shown here. You'll need to source fasteners that work for the mounting surface. The HCD 905 and 925 models should be mounted using these 3 locations. Use the 3 wall plugs and screws included in the box. If your controller is in a steel cabinet, remove the cabinet door as follows. Open the door, unplug the door earth strap from its tab, unhook the door hinge tabs by sliding the door upwards towards the top of the cabinet. Withdraw the door, the hinge tabs will slide out of their slots. Hold the cabinet against the mounting surface, properly square with the floor, and allowing 30 mm of clearance on the left, so that the door hinge tab system can work properly. Mark the locations of these 3 holes on the mounting surface. In the case of the HCD 902 and 922 combos, you'll also need to mark the hole for securing the temper plate. Lay the cabinet aside, drill the holes, and insert plastic wall plugs into the holes without their screws. When mounting the 902 cabinet, you'll need to tuck the temper plate tab into its slot and be sure to secure the temper plate to the wall, not the cabinet. The idea is if the cabinet is pried off the wall, the tamper plate remains fixed to the wall, causing its microswitch to close as the housing moves away, triggering the tamper alarm. Site mapping is essential preparation for the access control system commissioning stage. All Impro access control hardware quick start guides include a place where you can write down the name of the door where the hardware is installed. There is also a place where you can fix the spare address label that came with the hardware. Next we begin wiring door controls and readers. The printed cover makes wiring the distributed controller easy with all connections clearly labeled. If you've misplaced the cover, you can come back to the slide to find the terminal pins you're looking for. Take note of the input DC voltage that is printed on your controller, particularly if you're looking at connecting it to 24 volts. Do not exceed the rating on the lid artwork. Here is how you wire the request to exit and door open sense terminals. As discussed in the shopping list slide, you'll need push to make push button switch and a magnetic read switch. The distributed controller can monitor the door input lines for any attempts at cutting or shorting the lines. This will require both hardware and software step. For the hardware side, you need to install two 1 kΩ resistors in the circuit as per this diagram. The resistors should be located as close to the switch as possible, preferably concealed inside or under the switch housing. You'll also need to check the necessary boxes in the access control software. The three relays on the distributed controller have their normally open, normally closed, and common terminals accessible, providing flexibility to accommodate the desired action of the door lock. Choose a wiring arrangement that will deliver fail-safe or fail-secure operation as is required at the door in question. Mag locks remain locked as long as they're powered up. Strike locks typically unlatch when they're energized. Switching current through inductive loads produces voltage spikes that will cause sparking at the relay contacts. This causes pitting and corrosion. To prevent this and preserve the controller's warranty, you must make use of the provided metal oxide varistors. The most efficient way of doing this is to take the wires that will be connected to the relay and twist their strands around the legs of the MOV as you see here. Then secure these wire ends in the relay terminals like this. In this example, we are wiring a mag lock, so the wires are connected across the normally closed contact. The red wire would be routed to the plus 12 volts and the yellow wire would power the lock. The return wire from the lock must be connected to ground. The two reader ports can be independently configured for various devices by means of their associated dip switches. The first two reader port dip switches settings are for no reader at all. The reason we have these settings is to eliminate dormant addresses to optimize system speed. Communicating to many vacant addresses will slow the system. In AP light systems where the maximum address count is limited, you don't want addresses that do nothing. In the port disabled setting, the whole channel, including the associated door I/O, is disabled, but connecting an Impro multi-discipline reader will activate the channel. The I/O only setting allows you to keep the I/O for that channel active, so you can use that I/O to control the door without a reader, or activate a gate, or as a button input for emergency or lockdown, etc. Here's how to wire the OSDP readers to the reader ports. You'll need to set the dip switches for this reader port for OSDP. You can opt for with or without parity. OSDP readers should be paired with their controller terminals. This key exchanging process will be discussed at the end of the video after powering up. When you wire Wigan readers, you'll find colored labels to assist with the standard Wigan wire colors. Wigan options include these listed bit counts with pin or reason code mode and the listed IDEMIA series. Next there is Wigan open format, and then there is Impro's multi-discipline reader. You may notice this is the same setting that was used for no reader. This is because the distributed controller is designed to recognize Impro multi-discipline readers in this mode. Impro Quad Receiver allows the access control system to respond to a 4-button UHF remote. One distributed controller can handle the monitoring of any 2 of the 4 buttons. Choose the button you want the relay to respond to by setting the port dip switches as per the graphics here. If you need to accommodate the remaining 2 buttons, this can be accomplished by connecting the same D line to the D1 terminal on a second distributed controller. Both controllers must share the same DC ground reference. The controller modes are set using this set of dip switches, marked mode. Mode settings are best understood in the context of an installation. Distributed controllers are set to different modes depending on the functionality required at their location. System controller mode sets up the controller as a master for downstream door controllers via Ethernet as well as RS485 if needed. RS485 is useful when downstream doors are more than 100 meters away from the nearest Ethernet socket. Door controllers can be daisy-chained as far as 1,000 meters. A maximum of 64 addresses can be accommodated by each system controller, including the 2 taken up by the reader and the door ports on the system controller. System controllers must be connected by Ethernet to the access control system. In the event of Ethernet loss, all system controllers in Primo or Access Portal system will still control their RS485 downstream door controllers and keep time-stamped records of all access or tamper events. This data will be uploaded to the access control computer when the Ethernet connection is restored. Door controller mode sets the controller up as a slave unit that is only used to control its own 1 or 2 doors. In Primo or Access Portal systems, door controllers would ordinarily be controlled through system controller over Ethernet. In instances when Ethernet connectivity is lost, the door controller will continue to control its doors. If there are less than 10,000 credential holders loaded onto the system, there will be no noticeable change in access behavior. If there are more than 10,000 credential holders, the offline door controller will only allow access to those credentials it has previously allowed. In instances where door controllers are more than 100 meters from the nearest Ethernet socket, door controllers can be wired to the system controller using RS485. They can be daisy-chained as far as 1,000 meters. In the event of loss of RS485 connectivity, door controllers will continue to allow access to the last 10,000 credentials that they have allowed access to. They will keep time-stamped records of all access control and tamper records. These records will be uploaded to the system controller when RS485 connectivity is restored. In an access portal light system, the door controllers cannot use Ethernet. They must be connected to the AP Light system controller via RS485. If a door controller in an AP Light system loses RS485 connectivity, access will be granted only to those credentials that have been previously admitted. Timestamp events will be remembered and uploaded to the AP Light system controller when the RS485 connection is restored. Access Portal Light system controller mode is good for small businesses or residents. A maximum of 32 doors and 1,000 credential holders. The AP Light access control system runs on a web application on board the AP Light system controller with built-in help for all its functions. You can build an AP Light system with anything from 1 to 32 distributed controllers, only don't exceed 32 addresses. The AP Light system controller must be connected to Ethernet. Operators and administrators will then be able to log into the web application via browser, where they can administer and maintain the access control system. All door controllers associated with this AP Light system controller must be daisy-chained through the RS485 DC-SC terminals. We will now show the distributed controllers in a wired network diagram with their relevant mode settings. The AP Light system controller must be connected to an Ethernet switch. This allows secure access to the access control web application via networked browser. Additional door controllers in an AP Light system must be daisy-chained to the AP Light system controller via the RS485 SCDC ports. The most distant door controller must have its end-of-line jumper in place. In a Primo or Access Portal site, the access control software resides in a Windows PC and can communicate with door controllers via system controller connected to the same Ethernet. This is all good if there are suitable Ethernet ports available close enough to the doors that need to be controlled. When the distance to the nearest Ethernet port exceeds 100 meters, we can switch to using RS485. Door controllers can be RS485 daisy-chained to a system controller as far as 1,000 meters. A maximum of 64 fixed addresses can be served by such an arrangement. The system controller must be connected to an Ethernet switch. This connects the system controller to the access control computer. Door controllers are daisy-chained to the system controller via the RS485 SCDC ports as per the AP Light example. The most distant door controller must have its end-of-line jumper in place. Here is the RS485 daisy chain wiring in finer detail. Notice how the cable screen is connected. The screen drain wire is only connected to the system controller or AP Lite system controller. Short links should be used to connect the screens in the cable run. Take care to prevent shorting between the screen links and other wires. Leave the screen unconnected at the end of the cable run. Once again, remember to install the end-of-line link on the door controller that is at the end of the daisy chain. Before powering up, check the wiring. Make sure that any peripheral wiring, including door sensors and locks and other switch loads, is correct. Remove the real-time clock battery insulation tab. The 3-volt lithium button cell keeps the real-time clock running when power to the distributed controller is interrupted. If door controllers are linked with RS485, make sure that the most distant unit has the RS485 line termination jumper in place. When powering the controller with a DC power adapter, always check which voltage variant you have in hand. Those with the light grey lid with 90 item numbers and marked for 12 volt DC should be only powered from 12 volts. Those with the dark grey lid with the 92 item numbers and marked 12 to 24 volts can be powered with anything from 12 to 24 volts DC. The HCD 901 and 921 will need the mains cable to be wired to the mains terminal block, here with the earth on top, neutral in the middle and live at the bottom. Plug the other end of the mains cable to a mains outlet and switch it on. For the HCD 902 and 922, you will need to plug the IEC320 kettle plug into the socket in the left of the intelligent power supply housing. Connect the cable to a mains outlet and switch it on. For the HCD 903 and 923, you'll need to use the heavier Ethernet cable discussed in the spec tables. The other end of the Ethernet cable must go to a PoE switch or to a regular Ethernet switch via a PoE injector, as shown here. PoE power needed is 30 watts. All the steel cabinet combo versions include an SLA battery protection system designed to de-energize the battery relay when the battery voltage falls below a healthy threshold. This saves the battery from being ruined. If you connect a fresh battery to the steel cabinet combo without mains power present, you'll need to momentarily short out the jump start contacts to energize the battery relay. Do not leave this short in place as it will defeat the battery protection. The intelligent power supply has the jump start contacts next to the fuse over here. When the controller powers up, the power LED will come on and the status LED will flash continuously until the controller has been discovered and added to the access control application. Check that all the distributed controllers that have been wired in are in a similar state. Then take all the site mapping information and head over to the access control administration computer. This could be a computer running Primo or Access Portal. Or in the case of an integrated Access Portal Lite web application, you'll have a desktop PC or a laptop or smartphone that has browser access to the installation's Ethernet. Whichever system you're using, you'll need to log into the access control system with a username and password. Use the hardware discovery function then and add all controllers and readers that have been wired up. The site mapping info will assist with identifying individual distributed controllers and the correct naming of the doors. Now we have some important matters for AP Lite installations. The most likely reason to perform a factory reset would happen in an AP Lite installation when the AP Lite system controller has been inadvertently allocated an IP address that falls outside of the system mask. If at any time there is a need to default the AP Lite controller, all AP Lite user data will be lost. Before you have to resort to defaulting the AP Lite system controller, you should back up the AP Lite data using the firmware update utility. This same firmware update tool can be used to restore AP Lite settings after a factory reset is performed, or if the distributed controller is replaced for any reason. If you have set a static IP address, make note of it, as this will be reset when you perform a factory reset. On performing a factory default, the AP Lite system controller will get a DHCP assigned address. If no address is assigned by a DHCP server, the module will revert to this address with this subnet. Here is how you can default the distributed controller. Turn the controller mode switch 1 on. Then you'll need to cycle the power of the controller. Disconnect the DC power to the controller by pulling out the DC input plug here. Wait for all the LEDs to fade. Give it another few seconds. Plug the DC power back in. Give the controller time to default and reboot. Make it around a minute to be safe. Turn switch 1 back to off. If you forget this, the controller will default every time the power is cycled. When you return to the distributed controller in a Primo or Access Portal installation, you'll see that the status LED has stopped blinking and stays on permanently. This indicates the controller has good communication with the access control system. The status LED on the readers should also be shining solid red. If communications is lost, the status LED will begin flashing again. It'll stay on solid as soon as the connection is restored. Assuming that all connected readers have been properly added to the access control software, reader ports with OSDP readers will have their RX and TX LEDs rapidly and dimly flickering like so. In the case of Wiegand readers, the RX and TX port LEDs will flash brightly and slowly like this. In the case of downstream RS485 connections to door controllers, if they were successfully added to the access control software, the TX and RX LEDs for the RS485 DCSC port will be illuminated like this. You should now pair the new OSDP readers to their reader ports. We return to the two banks of dip switches for the reader ports. To initiate key exchange and cause the port to become married to a specific OSDP reader, you'll need to check the OSDP reader's instructions first. Make sure the reader is in install or pairing mode. Next, you toggle the first switch on the bank for that reader. Here we show how to pair reader 1. Turn switch 1 on, turn switch 1 off. At this point, the reader, if it's an Impro OSDP reader, will briefly flash white. This process makes sure that only that paired OSDP reader will work with that reader port. If you want to change the OSDP readers or move OSDP readers to a different reader port, you'll need to redo the pairing process. One last matter. If this is a new installation, make sure that the customer knows how to change from the access control system's default username and password to their own to protect from unauthorized system access. We have now reached the end of this video. Please like and share and subscribe so you don't miss any new Impro product videos.